All right. Hey, everyone. My name is Mohit. I'm a developer advocate here at Salesforce. And I'm joined by the product manager for sales for Apex, Daniel. You want to introduce yourself?
Hello, yes, as you said, I'm the product manager for Apex. It's great to see you all here so early in the morning.
All right. Now, before I get started, I see a lot of you already laughing on this slide. You know why. All right, so we are not going to make any forward-looking statement, but in case we make, please make those purchasing decisions based on, features that are currently available in Apex. And before I get started, I want to take a moment and thank you. Thank you for joining us and also sharing everything that you learn through our community. Actually, your ideas are the ones that help us to push and innovate better. So we take all of your ideas, we prioritize, and a lot of the content for this specific session is inspired by community. So we did a lot of research over the online communities. We saw a lot of cases that come to us for Apex, and we said, you know what, these are the set of topics that we need to discuss. So we're really excited for the content that we have today, and our agenda for today is going to be very simple. We'll keep it very simple, right? But we'll go into the deep, and that's why the session is titled like deep dive, because we really want to deep dive today. So we're going to be taking a deep dive into managing trigger recursions. How many of you have had this trigger recursions? Okay, a handful. That's good. Concurrency and record locking issues. Okay, a lot of you. That's great. We're going to talk about that, best practices to resolve them. Using schema describes in your org and having performance issues. Okay, many of you. Okay, we'll take a look at that. And how many of you are using asynchronous Apex, like queuables, batches, platform events? Okay, perfect. So we're going to explore, pros and cons of these, asynchronous, asynchronous options that we have at Salesforce, and we'll look at how, we can look at some of the considerations and derive some best practices out of it. So we're going to start with managing trigger recursions, and this is going to be a lot of code, actually. So, but before we get into code, I wanted to take a use case and show the recursion and create this recursion so we can go solve for that and look at, what are the solutions we have to solve for recursion. So here's a fictitious scenario, again, to simulate an recursion in an after update trigger. So I have a trigger basically on update of account. So this trigger is basically providing a discount for all the opportunities that are related to the account. Very common, right? I mean, you have account, you have opportunities, and then account can have this discount field, and then based on the discount field, I'm updating all these opportunities in my Salesforce instance. And then I have a trigger again on opportunities that's basically updating a field called last modified opportunity close date on account based on the close date on the opportunity. So you can see this is creating a recursion, right? So how about we code walk through a bit and see this in action. So here I am actually in my trigger, and I'm just writing a trigger just like any developer, Daniel.
Yep.
You know this, right?
Pretty
so,
standard one.
Yeah, pretty stable one. So here's my trigger. And Daniel is here to correct me actually on everything that I've written so far, kind of helping me here. So Daniel, this is a trigger on, you can see it's a trigger on an after update. I have a handler class, because, best practices, right?
Yep.
Make one trigger, you can control order of operations. So here I'm going here, and then what I'm doing is, obviously calculating that discount percentage from that account ID. And then using that discount and, doing this amount calculation here and updating that opportunity.
I like that you bulkified it. At least you didn't do that in the loop. That's good.
Okay. Pretty much everybody knows that, I think, at this point. So here's the opportunity trigger. And this trigger, again, is calling a handler class. And now what I'm doing here is, for all these opportunities that are coming, on update, right? I'm taking this opportunity close date and stamping it on the account, right? So this is a recursion scenario that's happening, because now the account will update, it'll kick off that trigger, it'll update opportunities, it'll kick it off. So everything will go into recursion. How about we test this, Danielle, through the UI? So how about I give some discount? So you can see here I have one opportunity, right, an account. So I have like an amount of $100,000 for an opportunity. I want to give some discount here.
They're a good customer. Can we give them more? Give them a bigger discount.
Always, always.
Yeah.
We want to give more discounts. We want to be selling with
50.
Salesforce.
Okay.
50, right? Try to save this. The trigger, and there you go. Beautiful error. Not unhappy.
Maximum trigger depth exceeded.
Yeah. So how about we solve this? And just like any developer, the first thing I do is like go look for how do I solve trigger recursions online?
Yeah. So what does your favorite search engine say?
My favorite search engine?
Yeah.
Use static booleans.
Okay.
We'll see.
It.
How about let's try that static boolean and
see what happens.
See what happens. Okay, so here we are. So first of all, right, I want to go deactivate this trigger, And again, the best practice is to write one trigger per object, but just to make it easier for us to see this in action, I've created multiple triggers, again, just for simplicity here. So I changed it. And Daniel will go here and look at the second folder that I have. So here it is, Daniel. I think this is a better approach. According to me, what I'm doing here is I have this handler class. I created a Boolean variable. This is what a lot of documentation over the online said. Use this Boolean, set it to true, and then look at that Boolean value, and if it is true, set it to false, so that next time when this trigger comes up, it will say false, and so it stops the recursion. How about I activate this and test it out? What do you think, Daniel?
We'll give it a go, see what happens. I think we'll learn something. But
yeah, I'm just going to deploy this.
Yeah.
Deploys, there you go. So we deployed it.
Try giving them that discount again.
Yeah, I'm just going to try saving it, now that I have this better version of the trigger. So go here. It seems to be working. You see, 50,000 is my account value. I copied this close date back to this close date. So
before you ship that to production, can you run some test cases? Like, what happens if there's more than one account?
More than one account. Okay, so I think I can. I have a test class. I'm a good tester.
Good. Yeah. Coverage, please.
Yeah. So I have. So I have a test case here. I'm going to run that and then explain a bit about how I'm testing this for bulk. I know all these best practices, Daniel. Yeah. I know all of these best practices of triggers to test. So I'm going to run this, right? And while this is running, all that I'm doing here is take 300 accounts. And for each of the accounts, I'm creating an opportunity, like you can see here. And then I'm updating with a percentage value. So I'm changing it from 10 to 5. And then I'm expecting that I assert that this trigger is working correctly, right? So it's going to take some time because we are doing for a bulk 300 records.
So what's going to happen with the trigger there? It's going to chunk your records into batches of 200 for that trigger, right?
Okay.
And so 200 are going to go into the trigger.
Okay.
Your Boolean's going to flip to false.
Okay.
And then the next 100 are going to come into the trigger, and your Boolean's still going to be false.
Oh, so you're saying that we'll have two different...
the trigger will fire in batches of 200.
Okay,
and the Boolean's not going to reset because it's static for the transaction.
Okay, so it's going to work for only 200 set of records, and for the next one, it's going to stop.
Yeah, and your assert failed. But that's good. This is why we test.
Did it fail? Okay.
Yeah, so your assert failed.
Okay, so you know what? I went back, I was researching on this. I went back. First of all, I'll deactivate this. But then somebody said, use static sets because, they said static sets, with static sets, we can keep track of these IDs, right? Yep. And then, how about that approach?
Let's try that and see
Let's try that? Okay. How many of you think it's going to work with static sets? Have you used static sets before?
So you're going to keep track of the IDs of the records you've already processed.
That's what most of the trigger patterns do, right? Okay. We'll test it out. We'll test it out.
I'm falling for it.
All right. So I'm going to go back to here. So I just want to make sure I deactivated this. I'm going to go back and activate this trigger and then quickly show you this example that I have. All right. So here it is with the static set, Daniel. Mm-hmm. And with the static set, all I'm doing is, let's go back and pull that Apex here. So recurs with static Boolean here, right here. So this is static Boolean. Let me just use the static set. So here it's the static set. So all I'm doing here, Daniel, is have a static set, okay? And then what I'm doing here is basically I am populating this set, once I execute the thing, right? So in this case, what I'm doing is adding everything to the set, right? But next time, I'm making sure that I only pick up those accounts to process which have not been processed yet. So if we have like 400 set of accounts, right?
Yeah.
I'm looking at, okay, these 200 are actually processed already. So let me just go and do this processing for only next 200 set of records.
It seems like it might do something for that trigger bulkification scenario.
Okay. So trigger bulkification scenario. So okay, so we're gonna go here, and should I just run it again?
Yeah, we could get it kicked off. And then, so what's going to happen? So the 200 are going to come in, and then the next 200 will come in. It will have clean IDs. It wouldn't have seen those IDs in the set, so we'll process them. But do we want to go into the more complicated scenario?
Yeah, and so the thing that's going to happen here, I'm pretty sure this is going to fail because we have account insertion and opportunity insertion too. And one of the things about Salesforce is sometimes when you have this parent and child relationship like this, for example, the special use case of opportunity, what happens is on an insert of the opportunity, there is an implicit update that has happened to an account. So it's going to kick off the account update trigger again. Even though I'm inserting an opportunity to the test class, it's going to still kick the the update of the account. So my static set will not work then, because what will happen in this scenario is that update would have compared the new and the old value and said it's same. So it's not going to execute or do anything.
That's quite common in a testing scenario. If you're using something like that, you might need to reset it before you actually start the thing you were interested in testing. Okay,
so we want to talk about this. So how do we then solve? And you also know that there is, so you see it actually failed again with static set 2. And this is very common, if you go look at any online forums today, they say you just use static set or maps. Honestly, it's not going to work for all of the scenarios. It might work for a few of them here and there, but it's not going to work and cover all your scenarios, like the one that I just showed you. It's not going to happen, because when you're inserting an opportunity here, there's an implicit update trigger that got fired, and your set actually looked at that and said, okay, the transaction has happened, so for the next time, it's going to stop it, right? So what is the better solution, Daniel? Like how do we then solve for this? I'm going to inactivate because this also doesn't seem to do its magic, which I was hoping it does, because the online forum said that it's going to work. So
yeah, it seems like the statics are not really working for us.
Yeah, static is not going to work.
Yeah.
Whether it's map, set, Boolean, it's not going to work. So I have a better solution, Daniel, which I think is going to work. So I am basically comparing the old and the new value. Since it's an update trigger, I know that there's an old value and a new value, and I'm doing a comparison. And I think this is going to consider all the use cases and scenarios for me. And I'm not relying on static set anymore or static Boolean variables anymore. So I just saved this, and we want to test it. But there is one big caveat that you want to mention in terms of, so I can run this bulk test. I pretty much know that it works. But here's the special use case that most of the trigger patterns there today doesn't consider, and we want to make sure that you are aware of that. So the use case is when you do a partial update. So imagine you're using a data loader and loading data into the system. So by default, at Salesforce, what we do is how we save these records is we do a partial update. That means if you have 100 records and let's say 20 records fail, what we do is we take these 80 records, try inserting, and then we again retry it. And then again, we retry it for 3 times, right? And this is a partial save behavior, very well documented. behavior, and it is applicable only when you're doing a data load or when you're using an Apex with partial save. Like for example, here you can see I'm using database.update to save it, and I'm intentionally failing one of the records so we can validate this scenario. So I have a
So you've set all or none to false there on line 214.
yes,
So
all or none to false.
In Apex, you have to explicitly opt into the partial save behavior. But with, say, something like a REST or a SOAP API call, you'll get partial saves by default.
Yes. And when you do the partial saves, as I told you, right, it's going to do what we call it as bulk retry. So bulk retry, what it does is it retries itself for a number of times before that thing gets succeeded. And during that, if you have a set, if you're using set for stopping the recursions, you will see that the set approach is not going to work. And we can prove it out here. If I run this, run this little test case that I've created, once I have that check for new and the old, you will see that most of the scenarios are automatically taken care of. So that's our conclusion here for you is like, when you think about designing these triggers, always when you have an after update scenario, make sure that you compare the trigger.new and the trigger.old. And that is one of like the key takeaways. It's like that can basically allow you to go further.
So yeah, the more idempotent you can make your triggers, the more resilient they'll be to recursion examples, bulkification, scenarios where the same trigger might fire multiple times for the same records.
Yeah, and you see with this scenario as well, it went and it passed all my test cases. But Daniel, let's come back to our use case. So you just talked about after update scenario. I understand there is a trigger.new, trigger.old. You can compare. How about insert scenario when we don't have that trigger.old? How are we going to solve the recursion there?
Yeah, that's a bit harder. Yeah.
How about we take a use case and look at it?
Yeah.
Okay. So here, there is a use case here where I'm inserting an account. And then I'm creating a task on an insert of an account. And then there is another trigger, actually, which basically creates a competitor account based on description field that it finds on task. And then this creates a task, and the task creates an account, and this gets into the recursion. Right? So this is another scenario. And how do we solve for this, Daniel? Because we don't have the trigger.old here to compare anything. And the set approach is not going to work.
Yeah.
Again, the set is, using static set is not going to work here because a new account is getting created. So your static set is growing in number, right? So you're not being able to remove everything. So how do we solve for that scenario, right? So we straight away get into the code. We don't want to run a lot of things because in the interest of the time, but I just want to show the approach that we are taking here. So we'll go to the handler, and in the handler, I have this, I'm back to Booleans.
Yeah, we're back where we started. We're back with a Boolean, a static Boolean.
Yeah, but here's the catch. If you ever have to use, first of all, we don't recommend using static Boolean, but then there are scenarios where you cannot do anything. I mean, there's no way than using the static Booleans. But if you end up using, look, what is important is, check it out here. So what I'm doing here is, I have this is account insert trigger to create set as false. And then if that value is true, I just return and don't go through my DML operation, right? And right after my DML operation, I switch that thing to say false. So with this approach, what we can do is, we are definitely taking control of that recursion, stopping it, but then again, allowing the trigger to go do its thing for next set of 200 records when it comes down.
So yeah, reset your state.
Resetting the state is very important. Whenever you have to do this static thing, make sure that you reset it. And again, there is no like one size rule for this. It depends on your operation, what you're doing, what sort of inserts are causing issues, and you have to look at all of them holistically and then think about, okay, I want to stop this, then create a Boolean for that, and then basically once you do the DML, just make sure you reset the state.
Mm-hmm. And then, yeah, so something with like an example like that, you might actually take it further and put exception handling to 100% sure you reset that static after execution.
Yeah, so if you're using trigger handler, just make sure that those trigger handler or trigger patterns that you get it from online cover all these scenarios. Because we've seen cases where customers have come to us and say, we have recursions and, we were using Boolean, but then you stopped the data load, because sometimes what happens is you use these Booleans in your thing, and, you fire a bulk load of, like, let's say 1,000 records, and the trigger did the logic only for 200 records, and then you have 800 records creating inconsistency in the data. So you have to be, like, mindful of that. So we just walk through the code. So here are some of the best practices that we recommend.
Yeah.
In terms of, yeah.
Shall I go through those?
Yes.
So yeah, as we talk, definitely the first thing you want to consider is bulk scenarios, and that should be part of your testing. What happens when there's more than 200 records, and what happens when those triggers fire multiple times. Then the next scenario that people often forget to test is setting all or none to false and having some of the records in that transaction fail. So as we showed, that trigger will fire multiple times doing the same thing for the same records as we retry just the successful records. And then also that will also cover the scenario where if you're coming in through an API, you'll also get that similar retry behavior. So in terms of best practices, now it's a bit depending on the scenario. As a general rule, avoid static variables wherever you can. Definitely static booleans and static sets if you're not resetting them. And then that should help. And as we mentioned, that has problems with bulk operations, the partial retries. Something we haven't gone into, which is potentially even more complicated, is platform events firing flow interviews. They will run as potentially within one transaction, multiple different users. And when they do that, they actually reset the static variables within the Apex transaction for each user that's firing for. So that's probably another good reason to try and avoid statics if you can, because that state is going to get reset within the transaction. As we showed, if you can do something idempotent in your trigger to actually determine if it should or shouldn't fire, like comparing old versus new values, that's a pretty robust scenario for most situations.
Yeah, and there's one more, I think, scenario that I've seen where, what happens is you have this triggers and then you have a workflow, and the workflow is going and updating the same field that trigger is doing some action on. So that's a very rare scenario. First of all, I would like you to think about avoiding that, but you have something in the org, even comparing old and new will not work, because when the workflow modifies something, the trigger.old value is the previous value. It's not the thing that workflow modified. So there's a catch there. And that's why we say avoid workflow rules, avoid mixing all these things together. It's going to cause problems. So you need to know the order of operations pretty well before you kind of solve problems like this. All right, so with that, let's move on to our next topic, which I think is my personal favorite because I have encountered this in a lot of projects, which is concurrency and record locking best practices here. So, for me as a developer, Daniel, concurrency is something that is very hard to imagine. Like, what is concurrency? How do I create a concurrency in my system? How does it happen? So how about I show a demo of a code that is creating a concurrency today in an org that I have.
Run through one, probably the easiest.
So let's actually go and look at one of the code examples that I have here. So we go here and look at this concurrency demo. So what we are doing here is a simple queuable class. And again, I'm doing this for creating concurrency in my org. So we have an account. I'm hard coding the ID just to show you. Don't do this in production. But we have a query which uses a for update. And for update locks that record for some time. That is how the for update works. So what I'm doing here is, so we have this, and it increments this number of employees field on the account object. And I'm updating, and I have a simple loop here so that we can hold that lock for some more time because we are creating. Remember, we're creating a concurrency
just for demonstration purposes.
Just for demonstration purposes. Yeah. So here's my actual code that is creating that concurrency. Is by I first reset my counter, update the account, and then I have 25 queuable jobs parallelly firing. So all of them are racing to get the same account record. It's like a race, right? Give me this, give me this, give me. Now, everyone is trying to access the same record at the same time. And that is where platform says, no, I have a lock in place. I cannot let another one take control, right? So the next one will throw this error that, unable to get access to the record. So let's see this in action. So it's visible, because a lot of these errors are like, we need to reproduce consistently. And that's why I have small code patterns for you to go show this use cases here. So I have a script folder here to make sure that we actually do this. So I'm going to execute this, Daniel. It's basically the same code that I just
So all
showed you.
25 queuables have started up, and they're all trying to update that same account.
Same account. This is that account. This is that account, and I'll show you what is happening. So we go here, Apex jobs. So we go here to the Apex job. By the way, is screen visible? So I have this Apex job, 824. That's right there. All of them actually failed. No, one of them is processing. You can see 2 of them is processing, but you see a lot of them failed because record currently unavailable. The record you're trying to edit or one of its related lists is currently modified. And if we are lucky, we could even try to edit it manually here, and you should see that I won't be able to. I have to be lucky for this. I'm not lucky at this time.
I think that most of them have already timed out.
Yeah, most of them have timed out. That's why, you have to be lucky because, when you're doing this UI operation, at the same time that asynchronous Apex needs to access this. So, but you can see what happened here is most of them failed. There are a couple of them which are in processing state. Let me refresh. Maybe those are also done at this time. Okay, as you see, there are only 2 things. So out of 25 of them, actually 2 of them went and succeeded.
But then if you look at the count on the actual record, what is it? It should be 2.
It should be like, it's 2 because only 2 of them succeeded.
Yeah.
We were expecting 25. I was expecting 25.
We wanted 25, but we got 2.
Okay, so what are the best practices then? Like in terms, if we have, we have this concurrency issues. I'm pretty sure, a lot of developers have put, asynchronous Apex like batch Apex or queuable, and then they have UI processes or Lightning Web components, that are creating these. So what are some of the best practices?
Yeah, so I guess if you're going to ask for a for update lock, you're going to have to think about what's going to happen if I can't get that lock.
Okay, so here's the other thing that I'm doing here. So only other thing that I did here, Daniel, is from my previous code is I'm catching that exception. Mm-hmm. So it's good to know you can actually catch these row lock exceptions. So you can catch, so I'm re-kicking it off, like re-enqueuing like with a minute delay. Yep. So my hope is like, with these delays, I'm able to get past more number of processing than I could.
Yeah. I mean, having the delay is good because it stops it immediately coming back and straight away trying for the same lock.
We can try it out. I think it's going to take some time, so I just tried it out, and so I'm just trying to do that. Again, only code change that I did was to ask it to retry manually. So what we should see is, again, there will be failures and stuff. You see most of them are processing. There will be some failures, some of will process, but the chances of processing will be higher this time. It won't be just 2 jobs, it will be more than that. So it's basically like first attempt retry, maybe we solve some of them. Second attempt retry, we solve more of them. So we improve the efficiency, right? So here are some of the best practices. Now again, that's going to take a lot of time because we have the delay there. So here are some of the best practices. And Daniel, would you like to walk us through some of them?
So yeah, definitely. If you are using you can use a for update lock. That's quite important if you want like exclusive access to a record. If you want to ensure your read is like reading the clean value and writing the clean value, you need to use the for update lock. But if you do, consider using some exception handling and a retry mechanism of some sort if you can't get it. Also remember, like we saw with the trigger scenarios, if you're updating a child record, it can also potentially cause locking on the parent record. That's quite a common scenario, especially if there's like a lot of fan out from the parent. You can get locking contention on the parent record, so that's always another thing to consider. But then depending on how your transaction's running, if it's synchronous, you might need to provide a manual retry operation for the user. If it's asynchronous, as we showed, you can queue the records together. Consider adding like a semi-random delay for the secondary job. So if there's multiple ones retrying, they don't all come back at exactly the same time.
Perfect. I want to go back and see, because I'm always curious what happened to this thing that we did. So a lot of them are in processing and queued state.
There's probably a lot getting re-enqueued.
Yeah.
But it will be safely chunking through.
But you see, we were able to move past at least that 2 number that we saw. So we are now 6. So
we created a lot of contention here.
Yeah. So, at least 6 of them we were able to process successfully. I also want to talk about other thing that we have seen is people use queuables for doing callouts to third-party system. And they think that they can use this for update in their query. So they lock that, log that rows while they do the callout. So I want to bring that scenario here and show that code example with the callout here. So here, all I'm doing is the same example, but I'm just doing a callout. And I want to understand the nuances of this. So will my for update hold when I'm doing the callout, Daniel?
So typically, we don't let you make callouts if you've got pending DML. And essentially, a for update lock is holding the database transaction open while you have that lock. So for that same reason, you can't hold a for update lock and make a callout. How it works today and has always worked historically is if you try that callout, it'll implicitly drop the for update lock for you, which may not be what you actually expected. You thought you had exclusive access to that record, but the second you made the callout, you lost that exclusive access. So ideally, you actually need to make your callouts before trying to take that exclusive access lock.
Yeah. So what Daniel, just to reiterate, right? If you have a code like this, we silently drop this lock and we let you do the HTTP callout. So if there is another process that's modifying this record, by the time your HTTP callout, let's say, takes some time and come back, this would have already been modified by some other process. So there is a data inconsistency that you might have if you don't understand that we silently drop this lock. Now you could explicitly put a set point here, like a save point, and then using that, I think it will not let you do the callout.
Correct. Yeah, you can't make a callout if you have an active save point. And if you release that save point or roll it back and release it, you'll actually roll back and release the for update lock as well. So that's another thing to bear in mind.
Yeah.
So those locks go away they get rolled back as well.
Cool. Perfect. All right. So here are some of the best practices or considerations, I would say, when you are doing Apex callout within Queueable with the row locking scenario, if you have it. It's pretty advanced cases. These use cases are pretty advanced. Last time we did a session, everyone was like, show us some advanced use cases, So we're like, okay, let's go one more level deep. So I hope, you're liking the content so far. So
I think we've pretty much covered those points, haven't we?
Yes.
That Scale Center is also another great tool to use.
Yeah, I want to call out Scale Center, Apex, Guru, all these tools are great because they tell you exactly this. The other thing that I want to discuss today is, and this is something that we got again feedback from a lot of social channels, is what are best practices for schema describes, if somebody uses these schema describes, right? So I want to show an example again with the code example that I have for schema describes. So here we go, so first of all, right, Daniel, when do you think somebody should be using the schema.getGlobalDescribe in their orgs?
Pretty rare you'd actually need a scenario where you need to completely understand every single get a describe for every single object in the org. That's a pretty expensive operation. Generally, I would avoid that.
Perfect. So that's our first thing, is avoid it if you can. We have given different security ways now using user mode data operations if you're doing, data operations in user mode. So really, if you can avoid this, you should. There's no question. But if you cannot avoid it, we have made it easier now with caching. By default, we run this in deferred mode, and you can see that first time it does take some time, but next time we cache it, so it does take a little bit of less time. But you should avoid this. But if you have a known object, right, the object ahead, then there is a very efficient way to do that is using deferred. So you can use the schema describe sObjects method, and you can pass in a deferred enum here, and that what it will do is it is much faster than using type.forName. I mean, these two are equivalent actually. So here I'm using type.forName, which is also another way to do this. Describes is by using type.forName, but I just want to call out that if you use deferred, you will see a better performance because I myself played with this and have done some analysis on the timing of that. And this is something to avoid. This is an anti-pattern, so please don't use it. So if you know the object in ahead, never go do get global describe.
Yeah, well, you're getting everything and then throwing away 99.9% of it, so it's a very expensive operation.
Yeah. So hopefully this gave you some of the things, and we just walk through the code. So here it is slide, a summary slide if you want to take a picture, and we're going to share the slides. We'll write blogs about all of this in more detail. That's our plan for this. So you have some content around some of these advanced use cases. The next thing I want to do is we have some time left, Daniel, and how about we do a lightning round of best practices for asynchronous Apex here. So how about queuables? What do you think about queuables?
So in general, I mean, and this is a rule of thumb for anything in Apex, the faster you can make it run, the better the general performance will be. It kind of stands to reason. Especially with something like queuables, it can be a bit of a trade-off. If you can make them run faster, we can schedule and run them better for you through the queue. But there will always be scenarios where you have long-running jobs, but try and keep them to a minimum if possible in queuables. And then, depending on the nature of your batch, the data you're processing, batch may well be the better process, especially if you know, I need to work through this fixed set of records. Batch is much better at working through batches of records than queuable, whereas queuable is more better with working with more undetermined or flexible scenarios. If you are using queuable jobs, make use of the various mechanisms we give you, such as control of what depth they'll run to, the deduplication control to remove redundant jobs, and the delays if you know you're going to need a standoff between running the jobs, such as we saw in the 4-update scenario. And then obviously with queuables, you can use transaction finalizers to make a more robust process. So again, batches aren't, then there's the reverse of that scenario, batches aren't the right solution for everything either. If you ever find yourself writing a batch with a size of 1, there's potentially something wrong there, and it might be a job that's better suitable to queuables. You really want to bulkify your batches where possible to make the maximum use of each execution. As with queuables, where you have transaction finalizers, with batch, you have the batch Apex error event, so you can handle those error scenarios and recover them from them suitably. One thing to balance with your batch jobs is if you are making a really large volume of callouts, trying to synchronize to an external system, there may be an alternative mechanism that's better suited for that scenario. You might be better off using platform events or an external service like MuleSoft to do that synchronization for you.
All right, perfect. Now I want to talk about platform events actually. This is very interesting to me actually, and I want to start off by showing a demo that kind of hopefully gives you an idea of why platform events has its own, a lot of use cases actually. So here I am in a platform event, and just like you can create triggers on everything, you can create triggers on platform events too. So this is a simple example that I've built together. So one of the things that platform events actually allow you to do is resume checkpoint. So this is something that none of these tools give you, like Batch Apex or Queuable. It's like if something fails, right, you have the ability to resume it. So even if you make an error in your trigger code, you can fix that trigger code and then resume it from there, and your records will be fixed. Same thing with data. Even if you have like a data which is like invalid and your Apex is not able to process that data, you can fix that data and you can resume this operation. So that's a pretty powerful thing. The other feature that platform events kind of gives you is able to chunk those records. So with the thing that you want, like for example here, right? I have like 50 number of platform events, and I can say, okay, process only in batches of 10. So I have that flexibility, There's 2,000 a max limit, but then you can chunk it to however you want, and that helps you in taking control of governor limits. Let's say you have a process which takes more time, then you can chunk it to a less size, and you have all that capability using this, things like, you can put an integer like this, a simple pattern that I'm showing, right, and maintain the count of records, and then say, after the 10, just break it out, and luckily it will automatically chunk the next 20, next 30, like that. And then you can always set the retry. By default, the platform events retry for 10 different times, but you can also tune it to say, okay, just retry for 2 times, and give me the thing. So just to show you an example here, right, what I want to do is I will go here and kick off a platform event. Again, this is like 100 number of platform events, basically. It's calling that same trigger, lowing trigger. And if the status is failed, I'm doing some operations. So I'm going to execute this. And you will see that here I have built a little monitor, and this is going to populate now after some time. So you can see it started doing it in chunks. But then when it encounters an error, and I'm forcefully creating an error, you will see the error. Once it encounters an error, it will stop with a replay ID, like you see here, divide by 0. It just stopped and said it retried for once. And it's going to go retry for 2. And I am stopping it for 2, but then it stores that replay ID. So you can always use that replay ID and replay back. So that's a pretty powerful mechanisms that platform event provide. And this is a tool that you can efficiently use to manage some of the governance limits of the platform. So we go here and look at some of the best practices here. So these are some of the best practices for platform events. You can take a screenshot of that. I already discussed a lot of these. This is a comparison slide, actually, if you want to have a slide which says comparison of all these things. Again, no one-size solution for everything. Everything has its own pros and cons. You have to look your business use case and then choose the right tool for the right job. With that, this is a QR code where I'll share, hopefully share the deck, with all of you. And also, we are looking for more content around some of these areas that we discussed. With that, I want to thank you, actually, for coming.
Yep. Thank you, everyone.
Hopefully it was helpful. Thank you.